Oh, good morning, everyone. I hope you can hear me loud and clearly and you can see the screen. If not, let us know through the chat. It's a lovely sunny day in London. So many greetings from the new UCL East campus. And it's my pleasure to welcome you to the Graduate Open events and that you're interested in the digital manufacturing of advanced materials MSc, which we're going to present you today. So we is myself and also Reza, who will help then also with the Q&A session after the presentation. So before I start speaking about the MSc in detail, I would like to say a few words about UCL, so the University College London, or as we also call it, it's London's global university. The university was established over 195 years ago, so almost 200 years ago, in 1826, and it was the first university in England to admit students from any ethnic class or religious background, and the first to welcome women on fully equal terms to men. And still today, we're still providing excellent and relevant research and teaching to the world. And this year is also a big year for the Department of Chemical Engineering. So we are one of the oldest chemical engineering departments in the UK, and we are celebrating 100 years of UCL's Chem Eng department. So it's our centenary year this time in 2023. A few more words about our outstanding and research and teaching experience. So UCL is ranked number 8th in the world and in the top 10 of the top 10 universities. And it might be worth keeping in mind when you're comparing these rankings that the UCL is of these higher top universities actually one of the biggest. So in terms of student number, and I guess you can imagine that that is quite something. So we are providing top quality research and teaching and allowing for rather high student numbers. So we're actually the largest university in the UK based on student numbers. We are top rated in terms of research strength from the Research Excellence Framework a few years ago. That's the numbers from the 2021. We are number 1 in terms of research power in London and number 2 in the UK in terms of research power. And we also have quite a few Nobel Prize awardees that have been awarded to 30 people who are either students or academic at UCL. And the most recent was 2020, Professor Sir Roger Penrose in physics. So I talked a bit about UCL. What is new at UCL? So nothing new in the West, that's correct, but quite a bit is new in the East, and that is the extension to UCL. So UCL is having its biggest extension since the last 200 years, so since our existence, and that is the new campus we are building in UCL East. Well, building is the wrong term, it's ready now. It's ready also for the new teaching, which will start in September 23, so this year. And this master program is the first one that will be held for postgraduate students. A few more words about this new campus. It's for nearly 60 cross-disciplinary and interdisciplinary research programs. It's part of London's East Bank, which is a new culture, education, innovation, and entertainment district. And it is home to the Manufacturing Futures Labs. And I will not tell much more about this because the Manufacturing Futures Labs are essential to this MSc program. That's why we'll discuss this a little bit more in detail later. But just to give you a little bit of an idea where we are. So the new campus is in the Olympic Park. You might know it from when the Olympic Games were in London. Or what you see here on the right side is the old Olympic Stadium. It's now the stadium of the football club, West Ham United. And right there at the heart of this Olympic Park are 2 buildings, which are very important for us. Is the one Poole Street building, which is not only for research labs, for robotics, urbanism, culture, and others. It's also home, it's a residential place as well for more than 500 students. That is very new and already open. And what you see on the right side, this is the Marshgate building. Yeah, the one shown now. This is the Marshgate building where there's a lot of research and teaching happening. And the Marshgate building is also home to the Manufacturing Futures Labs, which we'll talk a bit more in a few minutes. Let me speak a little bit more about engineering and the engineering sciences. So we're having a good home and we're having a very vibrant and multidisciplinary research here. So we're having departments in the engineering sciences from biochemical engineering, civil engineering, computer science, electronic, electrical engineering, mechanical engineering. So we have a whole range of very different disciplines, but I think I'd like to highlight that these are not islands on their own. So we always work together, and that makes it such a wonderful environment in terms of research. And also would like to highlight something that's not only valid for chemical engineering, but certainly for the master program, the digital manufacturing of advanced materials. You don't have to be a chemical engineer. And in fact, we very much appreciate to have multidisciplinary backgrounds. So everyone with a background in science and technology is very much welcome. And the digital manufacturing of advanced materials, MSc, is that multidisciplinary, that as long as you have a technical background, you will find a good home for your research and where you want to develop. I myself, for example, I am not a chemical engineer by training. I'm a physicist by training, who slowly evolved and went to pharmaceutical engineering and these kind of topics. So that's how I ended up in the chemical engineering department. But again, I am not a chemical engineer by training, and neither do you have to be a chemical engineer to be the perfect candidate for this MSc program. Speaking about chemical engineering and the department, what are the research focus we are working on in terms of research is catalysis and reaction engineering, which is very important to have processes more sustainable and running them at much less materials and much lower energy costs. We do a lot of electrochemical engineering in terms of fuel cells, batteries, and these things as well. Multi-phase systems, let it be fluidized beds, bubble columns, and the whole complexity that comes when you have multiple phase systems. We do a lot of computational process development, a lot of product and process and systems engineering, and very famous at UCL's Department of Chemical Engineering is the Center for Nature-Inspired Chemical Engineering. I would like to mention this one in particular because there is a separate MSc program called Nature-Inspired Engineering, which is also hosted at the Manufacturing Futures Labs. And we have optional modules, I'll mention this later again, in our program that are from the nature-inspired model. So if you're interested in nature-inspired chemical engineering, you can explore this through the optional modules of the Digital Manufacturing Advanced Materials MSc. And of course, another big research focus is molecular engineering and thermodynamics. Good. I already mentioned the different MSc programs we're having at the Department of Chemical Engineering. And especially I would like to highlight again the 3 new ones because they will be hosted at UCL East. That is MSc of Advanced Propulsion. That is, there will be a lot of electrochemistry, fuel cells, battery-driven vehicles, and these kind of science and research. And again, also if you're interested in these topics, you can explore them through the optional modules of the Digital Manufacturing of Advanced Materials MSc. I'll explain this again in a few slides where we're going to talk a little bit more about the program structure itself. I'm just giving you a little bit ideas in terms of numbers. So we have more than 500 undergraduate students. Usually postgraduate is of course much less. At the moment we have 90. These are rough numbers for the current year. And the department has around 33 academic staff and separate teaching lectures, also around 30. And a video I'd like to highlight, maybe Kate could put it in the chat as well, that shows you a 2-3 minute presentation again, a bit what we're going to do in the MSc for Digital Manufacturing of Advanced Materials. Good. Let me speak a bit why this program was born. What is the motivation for this? It's of course the massive industrial need, and I think it's very essential to mention that this MSc program was co-developed with industry. And why is it so important? Well, I don't think I have to remind you of how digital technologies, how artificial intelligence is changing the way we act as a society, even the way we write text, we listen to music, but also the way we develop materials. And we very much need new materials. We have new demands for energy generation and storage. We have new demands for healthcare and medicine, and then new demands for sustainable process development and manufacturing. Quite frankly, we need to find ways to produce materials and the goods we consume on a daily basis in a much more sustainable way with a much smaller ecological footprint. And in order to achieve this, as indicated before, we do need new materials. We do need materials that can do these jobs better, that can do jobs faster with less energy, more efficient, and produce more with using less. And of course, speaking about healthcare, to make things possible that have not been possible in recent years. That could be new drugs, that could be new ways drugs are transported, new contrast agents, new ways for cancer therapy. Speaking about the processes, we could, these are new catalysts to make reactions more sustainable. It could be more materials with a higher surface area, which is what we need for solar cells. We also need this for catalysts and every kind of multi-phase reactions. So there is quite a big scope where new materials are needed to help us tackle the global challenges we have. If you want to learn a bit more about UCL's commitment and the challenges UCL is committing to solve, have a look at that UCL's grand challenges as listed here on the left. So you might ask, well, that's good and nice, but why is it now so important to use computers? Which I guess is funny. I think the last 6 months even showed us what AI and machine learning techniques are already able to do. I think we all know they started making music, they started generating text, they start solving little problems and even big problems for us. We can now use machine learning and AI to do entire code development for us. So it's kind of obvious that we can use machine learning and artificial intelligence for quite a few tasks, and digital approaches can simply go beyond what humans can process. At least speaking about my brain, I do have limitations, and my computer many times gets much smarter than me. So I'm happy I can use him or her. Computers help us also to understand how materials work, and very important, and that's a key research focus of this MSc program, that computer-aided strategies help us to develop new materials and processes to manufacture these advanced materials. Let's think of a very simple problem. I have two parameters, two variables, and they're related. I could have, let's speak about a glass of honey, like a glass of jam or something we have in the fridge, or the butter if you want. And we know that the higher the temperature, lower the viscosity, and the lower the viscosity, the lower the temperature, the higher the viscosity, and the other way around. And if I would like to quantify this, and by quantify I mean it being able to generate a model, I could do a few experiments, and I could, in this case, I would be lucky, I would be able to fit a rather simple correlation. I could simply fit a line through, and that would do a reasonable good job. And what I would end up after fitting two parameters is a mathematical relation that allows me to predict the viscosity depending on the temperature. That's all good and nice, but of course we're not talking about honey, jam, and butter. We're talking about much more complex things. It could be, well, could be nanomaterials, it could be catalysts, it could be things for biological, for healthcare applications. So we're interested in many more parameters and much more complex dependencies. And what you see here on the right side, you don't have to understand yet what these things are. What I'm showing here is a rather simple but with many knots, a neural network. So that doesn't really show you the equation, but it kind of shows how things are connected. And what it simplifies here, what it exemplifies, is that if correlations get more complex and non-linear, we need very different models, we need different approaches to quantify things, and also to help us understand how variables are correlated. Again, coming back to the butter, it could be also the humidity, it could be the composition, it could be the fat content, etc. And then what it would affect is viscosity, color, appearance, taste, and all these things. But again, we will not talk about butter and jam, we will talk about much more complex materials. But the key point here is that if we want to unravel the more complex relationships and correlations between input and output, we need much more complex models. And even if we don't understand exactly the mathematics behind, there's always the shortcut through machine learning. But again, what we need is a lot of data points. For a neural network as shown here, we would need to fit around hundreds of thousands of parameters. You remember on the slide before, that was only 2. Now we're talking about thousands. And if you would like to calibrate such a model and you would ask someone in the lab, could you please do a few thousand experiments for me? but I guess it's clear to you that this person would not really be happy. So we need also different ways, not only to develop these computational models, but we also need new ways to perform experiments. Well, what do I mean when I say we need new ways to perform experiments and to analyze things? Let's start a few hundred years ago. And by the way, what you're seeing here is an image of the Faraday labs at UCL's Royal Institution. So you might remember Faraday from your textbooks, a very famous constant he had there. And I think even I did it in my undergraduates, where we did some electrolysis, having with a silver anode and measuring the weight of silver in the end to get this number. And his labs are still preserved, and you can have a look at them. And he was also working on gold nanoparticles. He still has, there's a bottle of gold nanoparticles that Faraday himself synthesized, and they're still colloidally stable, which if you're in the field, that would mean quite something. So he made these particles 100 years ago, and they still exist. They're still stable. They still have not agglomerated. And I don't want to say it's a mystery, but it's quite surprising that something that old is still working very fine. But again, this is not the point I tried to make. I just like to, if you're in London, also invite you to visit Faraday's labs, which are at UCL's Royal Institution. Well, where I was going with this, I was starting with experimentation. I was starting with, we need new ways to perform experiments. And that goes in two ways. We need more experiments because we're talking about hundreds and thousands of data. So we need high throughput experimentation, but we also need new ways to analyze materials much faster. And again, Faraday himself was working on these topics more than hundreds of years ago and invented quite a few apertures himself to explore materials in. Of course, this is old stuff, and labs these days look very different. And this is a very simplified screenshot. So if you go into a modern research lab nowadays, what you will see is a much more the use of robotics, the use of high throughput experimentation, the use of autonomous experimentation. So it's not the researcher putting things in a vessel, then setting the vessel at a temperature. Of course, I'm using very simplified terms here, but you'll see robots doing work for us. We're seeing things running overnight, that we program something and we come back on the next day, and hundreds and thousands of experiments have been performed for us. We see that robotics and autonomous system also analyze the materials for us, so that we come back after a coffee break, after a weekend, and we have thousands of experiments performed for us, and that can then help us thinking back of the neural network I showed you before to calibrate these models. So it's that goes hand in hand, that computational strategy, but very much also automation and high throughput experimentation and novel technologies for material characterization that make these things happen. And when I mean these things, I mean this nice integration of experimental and computational technologies. So, and that in a nutshell is the motivation to the digital manufacturing of advanced materials MSc. So what is so unique to this program is that we will not only teach the students computational skills, we will learn about mechanistic models, machine learning, artificial intelligence, and all these things. We will also learn how to work in the lab, how to synthesize materials, how to characterize materials, how to use robotic systems, how to use flow chemistry, and other techniques we use for high throughput experimentation. And we bring this all together to give you this fantastic multidisciplinary view, merging computer skills and lab skills, so that you have the entire holistic approach for digital manufacturing of advanced materials. So again, this is another diagram kind of highlighting the same. So what we are merging here in this program is material synthesis and characterization, process automation, high throughput screening, machine learning and AI, but also data science and computer simulations. So, and at the cross of all of this, that is where the program sits. We will talk a lot about manufacturing, about green energy generation. We will talk about drug molecules. We will talk about other innovative and novel materials, catalysts. I mentioned catalysts before to make processes more sustainable. We will talk quite a bit about nanomaterials, and the list goes on and on. And as mentioned before, this is not only something where we believe this is very important for the future engineers, that is also the feedback we get from our industrial collaborators. And that's also why this MSc program is very strongly influenced by our industrial partners. A nice analogy I would like to give for these things, and again, this is the bridge between the digital tools and the experimental tools. So I mentioned them before, and something that I might not have highlighted sufficiently is that there is also a big teaching element on things people don't always have in mind, but it's a massive bottleneck when merging these two experimental and digital technologies, and that is automation. So there are lectures specifically for automation. You will learn how hardware, how equipment is communicating with computers. This is very much a part of the program. You will learn how to develop your own neural networks and other machine learning techniques. You will learn how to combine AI with the actual hardware. So we will not only work on the computer, you will not only synthesize materials in the lab, you will also learn how computers speak to hardware. So you will also be there, lab view, automation, and these things are a big focus of this research program. And that kind of gives you the hat trick if you want, and that opens massive opportunities for digital manufacturing. As I've said, we'll talk about drug molecules, pharmaceuticals, materials for energy generation and storage, catalysis, facilitating sustainable processes, functional nanomaterials, for example, for precious metal recovery, biomedical applications, and many more. But again, the highlight I would like to show you here is it's the digital tools, it's the experimental tools, and also the thing in between that you learn how to communicate between the computer and actual things you have, the hardware you have in nowadays laboratories. So what are the program outcomes? We want to equip you with the interdisciplinary skills, so highly thought after by industry and academia. We would like to allow you to gain the abilities needed to develop and produce advanced materials. We would like to provide you with a holistic digital approach, combining up-to-date synthetic and analytic procedures, automation, data science, and a variety of computational tools. And of course, that you learned through case studies and open-ended research questions, also developed by our industrial partners. Now we're coming to the program structures. I mentioned a few bits before. I already mentioned that there will be optional modules, but what you see here now, these are the non-optional modules. So in term one, we will start with the basics. We will start with the basics on high throughput material chemistry. We'll talk about synthesis. We'll talk about characterization. That's where we'll also start talking a bit about robotics and flow chemistry. And you will also learn the fundamentals of data science. You will start to learn a bit about coding. You will start learning about how to use Python. You will start to understand what data science is. And at the end of this fundamentals of data science, you will also know a little bit more about machine learning, and you would have a better understanding how these modules work. And in the applications of digital materials manufacturing, you will already apply this while you learn this. So you learn the tools in the first modules, and the application of digital materials, you will learn about how this is actually used in practice. And you have nice exercises in our new computer clusters where you also do these things yourself. Term two, this is where the bottleneck is addressed. In term two, we have a module specifically designed for you to learn about automation. I mentioned the communication between hardware and software and the computers. So this is specifically addressed in the term two, automation and materials manufacturing. And this is a massive module. It's the data-driven materials manufacturing, the integrated module. So this is where we go in the lab. This is where you will actually have hands-on experience with flow chemistry, with robotic systems, with material characterization. We also bring you in touch with the massive research facilities we have in the Manufacturing Futures Labs, but you will spend a lot of time in the very up-to-date, high-end equipped teaching facilities where, as I've said before, you will operate robotic systems, flow chemistry, and automated platforms yourself to produce your first advanced materials. Term three is a bit more reserved for the assessments, and they're also dedicated to the MSc research project. So you will have to do a research project in the field of digital manufacturing of advanced materials. And this is also where industrial collaborations would be factored in. Good, I talked about this, and coming a little bit back to the optional modules. So there are 2 optional modules you can pick. One is from the module block B and one is from the module block A. And this is the list what these module blocks contain. So if you want the module block A is a bit more technical, you can learn more about topics such as advanced characterization. I mentioned before the modules from the nature-inspired program, from the advanced propulsion program. So that's why you can also use these optional modules to explore, for example, electrochemical materials. You can learn about fundamentals of nanoengineering, which is a module run by the Department of Mechanical Engineering. Yeah, and of course, the nature-inspired topics as mentioned before. Optional modules B might be a little bit more on the soft skills side. So we have courses there, modules like Find Your Future, Foundations of Citizen Science, but also entrepreneurship, theory and practice, exploring power inclusion and exclusion with local communities, etc. So that gives you, if you'd like, a bit more outreach and very different topics, a bit, I don't want to say less technical, but a different background that you also need to succeed in the business environment. Who are we? So what you see here is that the program team, we are now complete. So I have the honor of being the program director of this MSc. We also have Dr. Payman Mokam, we have Dr. Lauren Lee, we have Dr. Reza Bassi and Solomon Baba, and also Izzy McKay. So all 6 of us together are running the program. As you can see, we have very different technical backgrounds, and not all of us are chemical engineers, as mentioned before. So the 6 of us are very much looking forward to hopefully visiting you in September 23 at the Manufacturing Futures Labs. Let's talk a little bit about teaching and assessment styles. We'll have different modules. We'll approach teaching and assessment differently. So of course, we have computational models, we have lab-based modules. They will be assessed in very different ways. We have a lot of face-to-face sessions, which include group work. We have guest lectures, so we have our industrial partners also giving you guest lectures so that you can learn firsthand, and also through question and answer sessions with our industrial partners, how your new skills would apply there and what their industrial demands are. But it's typically a mix of coursework, reports, exams, and also group work and quizzes. We have formative, but also summative assessment to guide you through these MSCs. So let me go to my last slides. I mentioned quite a few times the Manufacturing Futures Labs, and that is something very, very exciting for us. This is how it looked a year ago. So we only had the nice pictures to show. And I think the very first open event, I was able to show this, but now I'm able to show pictures like this. So the thing has materialized. It is there. That's the Olympic Park campus. If you followed the Olympic Games quite a few years ago in London, you might still remember that statue. The West Ham Stadium is right here. So yeah, I don't think you saw my cursor before. And the Manufacturing Futures Labs are in the Marshgate building, in the penthouse, if you want, so the highest floors of this Marshgate building. So we'll have a fantastic view there. That is where the Manufacturing Futures Labs are, and the MFL, the Manufacturing Futures Labs, is where we host this new master program. What it is, it's a multidisciplinary research hub. It's to educate future leaders and highly skilled individuals who are both socially and environmentally responsible. And something I'd also like to mention is our website. So if you want to see what is happening at the Manufacturing Futures Labs, please have a look at this link as well. But it's also worth mentioning, it's not only chemical engineering. This lab is shared between chemistry, mechanical engineering, biochemical engineering, and chemical engineering. So it's a truly interdisciplinary, multidisciplinary hub where different engineering sciences and technology come together to work on future manufacturing topics. Also important, our neighbors there is the Center for Robotics and Autonomous Systems. So we're in good hands for all the automation related topics as well. And also new, I can finally show some pictures, how the campus looks like. So as I've said, we just had the handover. So it's officially now a UCL building, and we're equipping it now with all the high-end analytic equipment we bought and we are still purchasing. So the labs are coming to life so that they will be ready in September 2023 for you. That is a screenshot not a screenshot, these are pictures from the manufacturing futures labs inside from the Marshgate building. We will have fantastic lecture theaters there as well. So everything is absolutely brand new. We of course have fantastic teaching facilities as well. So we have amazing, very big labs made only for teaching. So these are laboratory facilities made specifically for teaching and education. What I show here is a picture of the wet lab. So we even have a nice view from the lab, which is quite rare in London. I can promise you that. Some examples, what you see here on the left, we have quite a few high-end see-through fume hoods. So we can watch from all different sides what is happening in the fume hood. If we use these fume hoods, for example, we might put some reactors in there, some robots, some flow chemistry setups. Whenever we work on something where we might work with not super safe materials, that's when we have to work in fume hoods. And that's why it's very nice that we have them see-through. We also have double floor ceilings, meaning that we have teaching facilities where we can actually put industrial scale equipment. And of course, not shown here, we have labs for automation, electronics, and the massive research facilities. So we'll not only have the teaching facilities, you will also be able to explore with us the amazing things we're doing in the manufacturing futures labs research facilities. Before coming to an end, I would quickly hand over to Kate to discuss the bursaries and scholarships quickly.
In terms of scholarships, bursaries and funding, UCL can provide advice to you on your options, and this will depend on your individual circumstances, whether that is your country of residence or your financial background. Scholarships and bursary opportunities are normally available at UCL at either essential or departmental level. Some might be announced throughout the academic year, so some additional ones, but equally some close earlier than others. So I would recommend keeping an eye on the deadlines for those. You can find the scholarships offered and accepted by UCL on our website. So the two websites in question I would recommend are the Central UCL Scholarship and Bursary Finder, or our department bursaries and funding page, which may be updated throughout the year. UCL accepts scholarships offered by external organisations, and you can find these either on the Central Scholarship and Bursary Finder tool, or you can look at external scholarship finder website and see if they're accepted by UCL. Scholarships and bursaries are generally assessed on the basis of academic excellence or financial need, and sometimes a combination of both, and sometimes they might be available to you if you are from a specific background. They usually have a guidance attached to them on the post, which I'd recommend reading through because that can help you answer the questions to the best of your ability. Some examples I can think of at the moment are the UCL Global Master's Scholarship, which is for international students. The deadline for that is coming up quite soon. It's on the 27th of April, and you have to have submitted an application to a master's course at UCL in order to apply for that scholarship. And the last one is the UCL Master's Bursary, which is I think it's a financial needs scholarship for UK and Ireland students. And the deadline for those last scholarships are in June, so you've got a bit more time. If you have any questions, you can put them in the Q&A, and I'll do my best to answer them.
Perfect. Thank you, Kate. Good. Well, I think we're almost there and open the Q&A session. The last slide I have, if my computer wants to join. Yeah. Where we are in London. I don't think I have to say much about London. It's one of the world's most multicultural and vibrant cities. I myself moved to London 6-7 years ago. I haven't been bored since then. I can promise you that. It's very hard to get bored in London, and you know what they say, if you're tired of London, you're tired of life, and I think there's a bit of truth in that. It's not only the amazing universities we have here, and also the amazing things that are now happening around UCL and UCL East. We're simply based in the heart of London, so you're not only, London is big, but UCL itself is at the heart. So the campuses are right in the center, and it's just such a vibrant, healthy, and energetic place, and especially these times is super beautiful right now. I don't want to lie, we have a little bit of rain in the winter, so that that is a fact, but you would be surprised how nice the weather actually gets, except the month between December and February, I would say. So it's just a wonderful place to be. And I don't have to make a commercial about London. I think you all have heard about that city. And that's where I'll leave this slide. And the last thing I would like to do is to say thank you. Thank you to Kate. Thank you to our comms team. And thank you to you for joining today. And also thank you to Reza, who is here, and also Payman. I showed them quickly before when introducing the program team. So they're here as well to help with the Q&A session. So thanks to all of you, and we're looking forward to your questions now. Or in the meantime, I might address the job opportunities myself. It's always, and I think that's an experience you have in many open days, that programs will say, look, you will be highly sought after in industry. And I understand if people do an MSc program, they're interested in either afterwards following a PhD, but also very much industrial careers. And what I would recommend you is just going to job sites. Whatever it is, if you're up for a PhD, or if you're interested in an industrial career directly after, have a look in and find a PhD, other websites, have a look at job sites in the country where you would foresee your future career. Let it be the UK, let it be another country. Go at job sites and have a look what skills are in demand right now. I bet you will see a lot of digital manufacturing, a lot of data science, a lot of robotics and these topics. So I think the job market itself should be the best advertisement for whatever program you're after. So I think this is a general comment. Whatever you would like to study, think of two things. How many graduates will this program generate? How many graduates will something generate? And how many job opportunities I have there? And I think the logic bit would be, have something that you enjoy, where you see that meets your interests, but also where you see the skills I learned there are really in high demand. So I'll be incredibly competitive afterwards, either to pursue an academic career or also an industrial career. And both is very easy to find out just by checking the offers, either for PhD opportunities or industrial openings in the country where you foresee having your career.
Do you have another question that's just come in? Is an internship a part of the program?
Reza, would you like to have a go at that one?
Yeah, sure. Well, we do not have an official internship, but there are numerous opportunities for you to do internship in the related companies. And by related companies, I mean you have a lot of choices when it comes to digital manufacturing and data science. It can be in pharma industries, process industries, energy generation and storage companies. So yeah, we do not have an internship officially, but you have a lot of opportunities to do so.
I think a bit adding to this, it's a one-year program. So the one-year program, it would be very hard to have like a 3-month internship somewhere, because you would have to wait then an entire year till a module is taught again. So quite frankly, the program is a bit too short to have significant industrial exchange events happening in there. Just to let you know, there will be, of course, the guest lectures by our industrial partners, so that is some face-to-face contact you will have with industry for sure. And of course, we are also planning to have our industrial partners be part of the MSc projects themselves. So that is another opportunity to be in touch directly with industrial partners.
There's another question. Can the tuition fee be spread out through the length of the program? So yes, the tuition fee can be split into 3 installments throughout the academic year. The first has to be paid before you enroll, so before September. There's no advantage to paying it in one go, and you don't get a discount for if you pay it all in one go versus if you pay it in 3 chunks. There are specific dates for the installment deadlines, which I'm going to post in the chat now, but I hope that answers your question. And there's another question, which is, while evaluating applications, what specific qualifications and qualities are you looking out for in a potential student?
I'll take that one then. As this program is very interdisciplinary, so we will talk about coding, we'll talk about machine learning, computer simulations, and very much the experimental aspects as well. We will never expect a student to be good in all of them. This is just not possible. No one has studied 5 different things. So we very much welcome everyone with a scientific, technological background. So it's not like we're looking for someone who is able to do all of these things already. No, because these are the things you will learn in this program. What we are interested in is that you have either a background in mathematics or that in engineering, in science. So we very much welcome applicants from biochemical engineering or other engineering disciplines, physics, mathematics, material science. Everyone who's also curious to learn new things is very much welcome to apply. And being a bit more specific, as what is important for us, again, that you have a scientific mind, an engineering mind, that you are familiar with science, technology, and mathematics. So this is something that is relevant. I think you would not enjoy this course if you would have studied literature or some social sciences. That would be then too hard, I think, to follow up. But everything from the STM background is I think, a very good fit for this. And of course, you need to bring the curiosity to learn new things. If you have industrial experience, if you have already worked for quite some time, even in 1 year, please highlight this in your CV, because that will also be considered. So we very much also want people who already have spent some time in industry and would like to explore what's else and like to educate themselves and learn more. They're very much welcome. So by all means, if you have this, if you already have some working experience, please make sure you highlight this in the application and in your CV.
And there's another question which says, I have a bachelor's in chemical engineering, but I've worked as a data scientist since graduation, about 3 years now. What are my chances, seeing I've had no experience working as a chemical engineer?
I think I just continue speaking because I think that's what I started answering in before. Again, we cannot and we do not expect someone to have experience in all these different disciplines. And you don't have to have worked as a chemical engineer. And in fact, that you have industrial experience is already quite something that is quite remarkable, and that you have an undergraduate in chemical engineering. So you have this in your bag, and you also have work experience in data science. That already equips you with quite a lot to be an amazing candidate. As I've said before, we would not expect candidates to have mastered different disciplines as you have done with chemical engineering and data science, one via academia and one through your profession. So we cannot expect this from students, and we do not. So the fact that you already have experience in multi-disciplines is quite amazing. So, and again, if you would consider an application, I would like to remind you again, please strengthen out in your application that you have industrial experience, that you have worked outside university, and 3 years is already quite some time. So if you consider applying, please make sure your application gets that across, and also gets across that your curiosity to learn other things. We cannot expect, again, I'm repeating myself, I know this, we cannot expect students to have experience in all these disciplines. How could they? this is not what we expect. We want that our graduates have this experience, but not our applicants. So by all means, what you're saying here is already much better than we were thinking applicants could be in terms of interdisciplinary, multidisciplinary experience. I will also put my email address in the chat. So if anything comes to your mind, by all means, any questions related to the program, reach out to us, reach out to myself. We can also have a quick one-on-one follow-up at a later stage to answer any questions that pop up later or that you didn't think of now. So we're also very much happy to follow up with you after this.
Someone has put a question in just now. They've asked, when do we need to submit a research proposal, and will we be assigned a mentor for our research project?
I guess this question is referring to the MSc in term 3, the MSc research project.
They haven't said, but I would assume so, yeah.
The topics will be available in around after Christmas, I would say. I don't want to give any exact dates because I cannot promise they will be done the 1st of January, the 10th of January, but around that time, there will be a list of projects. And of course, you will have a mentor, you will have an academic assigned to it. So every MSc project will have an academic supervisor to supervise the student. Definitely more than a mentor. So every MSc research project you do in very close collaboration with an academic. So this is not like a classic coursework. So this is a very nice thing, actually. You spend a lot of time, and that's something I always enjoyed, having MSc project, because it gives you the chance to work directly with students. And that's a very new experience for students as well, that they work on very open-ended research questions. And then you start having scientific and technical discussions with the students where sometimes no one of us knows the answer, but that's the very entertaining bit, if you want. And it's a very enjoyable thing that you and the student work that closely together to see what can happen. And sometimes we work on projects and we don't even know how far we can get, and of course depends on the student's skills and motivation what is possible in the end. But yeah, it's a very close collaboration and working together between the student and the academics.
I think maybe last chance for any questions, and then we'll finish.
I think one last time, big thank you to all the attendees and of course to you, Kate. Thank you very much.